Good afternoon, everybody. Well, apparently my camera's closed. That's why you can't see me. How we doing? As always, nobody's in here, so I don't know how many people are actually coming down and watching the videos, but so be it. I think I see Emily, you're the only one that's showing up for me right now, but there's some people that could be stuck watching ads and stuff, so they might be jumping in a little bit. But Hannah, did you not see the second email that I sent you? I sent another email saying that if you could figure out the password and you can sign in through the browser instead, you should be able to do it from the website. So once you go into the website, you click on my name. You'll see in the top right corner, you'll see a little bell, and then you could click on that and the following thing will come on. I can't figure out how to do it without going to the website, though, and I couldn't find anything online. So I don't know. How about it? So Emily, since you're in here, you weren't here earlier when we were talking about it. Do you get updates on your phone when I go live, like a notification or anything like that? Because half the people are saying they're getting the notifications and half the people are saying they don't. So I don't know if you're just jumping on because it's 4 o'clock and you know that's when we start, or what. It looks like today's not going to be too bad at all. I don't even think I'm going to do all of them. It's just going to be more review with Piecewise. So it's only sometimes, though. It doesn't give it to you every time. I don't know. I can't figure it out. All right. So I'm going to probably only do like the first three problems on here because four is going to be the same thing as 3, so I don't really care about it. All right, so I'm going to start off with the first one. This is kind of like one that we did last week, and you guys had one. Okay, so you did get that one. I don't know then. This was kind of like in lesson 7. Lesson 8 is a continuation, just doing more practice with the piecewise to make sure you guys are good. So piecewise, in this particular problem, number 1 is being split up into 2 pieces. We got that top piece, and we got the bottom piece. When we go to solve them algebraically, we just have to figure out which one of the x's, or which one of the equations the x can fall into. So if we look at this x equals 10, we're trying to figure out if we could plug it into the top equation or the bottom equation. Well, in order to figure it out, we're just looking at the domains over here. So if you look at your domains, you have to figure out where 10 will go in and work. And I will tell you guys right now, the wind is getting crazy up here and my lights just flickered. I don't know if you saw it from your end. So if all of a sudden I just disconnect, it's probably because I lost power. The town over from me just lost power as well, so it could possibly happen. Sorry to cut into the middle of the problem, but just so you're aware. So if we're looking at 10, if we try plugging it into the first one, oh, your power did just go out? Oh, wow. So mine just flickered like crazy, and I'm still good. I don't know how everybody else is in here. I see some more people are jumping in. So if you just jumped in, you didn't hear what I said, my power's flickering. The town over for me just lost power, and I'm expected to lose power soon. So if I just kind of cut out, sorry. It's just flickering? Okay. So if we have x equals 10 and you were to plug it into both equations, if you try plugging it in, or inequalities, if you try plugging it into the top one, it'll say 10 is less than or equal to 4. That's not true. So we have to plug it into the second equation because 10 is greater than 4. So this 10 can be substituted only into the second equation. So this is all we have to do when we're solving it algebraically. Now that I plug it in, 2 times 10 is 20, and 20 plus 7 would give us 27. So if x is equal to 10, then our solution would be 27. We're going to do the same thing, for part B. If we have x equals negative 1/3, we can take that negative 1/3, figure out which one is the correct one it can plug into. It's going to have to be the first one because it's a negative number and it's a fraction, and that is smaller than 4. So I can plug it into the first equation in this case. So negative 1/3 minus 1. If you guys go to solve that one, 3 times negative 1/3 is really just negative 1 minus 1, which would just give us negative 2 as our final solution. Okay, so that's algebraic. Algebraic, plugging it in, that's it. Okay. Now I'm going to do the next two graphically. I'm going to do one where we're graphing the lines again, and I'm going to do one where we already have the lines and we have to write down the equations. Okay. So this one, I didn't give you guys a grid because I was just going to have you guys draw it in. I just want you guys to draw your X and Y axis like I'm doing right now. So this is the Y, this is the X. This piecewise function has 4 parts. We have 1, I'm going to color code it to make it a little bit easier, 2, 3, and 4. All right, so we have the 4 different parts. We have to start with the first and just work our way over. And I just noticed that I have to make my number line come over here just a little bit. We don't have to go too far. And the only reason we have to go to the left a little bit is as I'm looking at that first equation, it says that the answer is 3 from negative 1 all the way to 2. So what I'm going to do, and I'm going to graph it the same way we did it the other day to make life a little bit easier for us. I'm going to go up to the number 3. I'm just going to put a dot. This is where 3 is. What I'm going to do is I'm just going to draw a horizontal line that goes all the way across. So that line is representing y equals 3. Now we only care about the answers that fall on the x-axis from negative 1 to 2, and that's it. So what I'm going to do is I'm just going to put a little mark down here at negative 1. I'm going to put a mark over here at 2. We only care about the answers that fall between those two numbers. So what I'm going to do is I'm going to look at this number line, or this interval that I have up here. Negative 1 shows that it is, I'm doing it with my mouse and you guys can't see it. I'm going to look up here. This little symbol right here is saying that it's closed. So I got to put a closed dot over here at negative 1. And it goes all the way to 2. But once we get to 2, you guys can see that the symbol does not have an equal sign, so it's got to be an open circle over here at 2. Now after you guys draw it in, I told you guys the easiest way to actually graph it now is erase the part of the line that does not fall between those two dots. Oh, I am on big eraser right now. So I'm erasing that part. I'm erasing everything over here. And now I have my open and closed circle. So the first one's done. Now I'm just going to repeat this process. The next part of the function's at 5. So I'm going to put a little dot up here at 5. And I'm going to draw a horizontal line that goes all the way through 5. In this case, it's going through the numbers 2 to 4. And I probably should be putting these a little bit closer together because we have to go all the way up to 12 eventually. So now I'm at 4. And it says at 2, it's going to be a closed circle. So I'm going to go up to that red line, put a closed circle at 2, 5. And then at 4, it looks like it's going to be an open circle again. If you're confused with anything that I'm doing right now, please stop me so I can go back and over-explain if I need to. If you guys are watching the video of this later, send me an email if you're confused with anything that I'm doing. Now I'm just going to go on and do the next line. I'm just going to keep repeating the process. So now I'm going all the way up to 8. So at 8, again, I'm going to draw in my line. In this case, it's going to be between 4 and 9. So I already have my 4 down there. I have to put another mark for 9. I know they're not spaced out real nicely, but I'm just trying to get it to all fit on the line down here. So at 4, it looks like that one's going to be a closed circle again. And at 9, it looks like it's going to be open. And just like I did before, I'm just going to erase off the part that does not matter. And then I'm just going to do that last part. So now I'm all the way up here to 10. This one is going to be between 9 and 12. And in this case, it looks like the 9 is going to be closed and the 12 is going to be open. So everything that we're doing here, this is called a step function because they kind of look like stairs. And that's it. We drew the piecewise. We're done. Step functions are probably the most popular piecewise functions because in society, this is how like post offices use shipping cost. So it may cost $3 if, where's the button? Right here may represent $3 for this weight all the way across. Right here would represent $5 and so on and so on, no matter what that weight is. So if the weight's between 2 and 4 pounds, maybe the post office will charge you $5. If the weight is between 0 and 2 pounds, they'll charge you $3. And that's usually how the system works for post office and postal care. So now number 3, it's going to be very similar to what we did last time. We're just going backwards with it. The graph looks like it printed off a little crooked. I guess both of them did, so it doesn't really matter which one we do. But I'm going to zoom in on number 3. Again, we're just going backwards now. So we're looking to create the piecewise function. So I'm just going to write off to the side. I'm going to do my squiggly bracket. And our goal is to find our 3 equations. And there are 3 different parts here. I'll do it in highlighter so it's a little bit easier to see. Gotta shrink this down a little bit. We have this line down here. How do I want to do this? Yeah, I'll do it in highlighter. So I'm going to extend this line so it goes all the way through. And I got to do it for every single line. Oops. And our goal is to find the equation for all 3 of these lines that are here. Then we also have this last one. Now, you want to try to stay in the same order that the lines were originally drawn. So you always want to go left to right. So I'm going to zoom in on this. So we see 3 lines, and the red one is the furthest one to the left, but we have to base it on the graph itself. So we have to start with this arrow. So the blue function is what's actually coming first. So the first thing we want to do is figure out what that equation is going to be. So if we want to find the equation of this blue function, we need 2 things. Because it's a line, we have to put it into y equals mx plus b form. So the 2 things we need in order for it to be a line is the m and b values. Well, if you look at your graph, the b value is where it crosses the y-axis. And then your slope, the m value, is your rise over run. So hopefully that's looking familiar to what we did last time. I'm going to move this over a little bit. I don't know why I went so far away. So our first equation is y equals, well, our m looks like we're going up 1 over 1, so it's going to be 1x. And our b value is crossing through positive 2. So I have 1x plus 2. So if you're confused on how I just got that equation, don't be afraid to ask. I'll help you guys out. But all I'm doing is just going right through and just labeling that down. So now that was the blue one, because that was the first line that we started with. The second line looks like it's going to be our red one. And then once again, we're going to do the same thing. It looks like my y-intercept is going to be at 3, but we also need to know the slope. So I know it's going to be at +3, and it looks like the slope, once again, is just going to be 1x. And now we have to do that last equation, the purple one, or pink one, or whatever color is coming up. And it looks like, again, the slope is going to be 1/1, and it looks like it's crossing at 1. So once again, it looks like it's going to be 1x, but it's going to be +1. So we have the 3 equations. Now we just have to determine the pieces, and we can call it for today. So the first piece looks like it started at this arrow down here. So we know anytime we have arrows on a line, that means it's approaching infinity. And it's going all the way to just this dot right here. I'll zoom in a little bit more so you guys can see where I'm drawing the dot. So we know it's going from negative infinity all the way up to the x value of, it looks like -1. So I'm going to put down negative infinity all the way up to the x value of -1. And we're only allowed to put the equal sign on closed dots. So since at -1 it is a closed dot, we can put in the equal sign and we're done. So I'm just going to repeat the process, but now I'm going into the red equation. So the red equation looks like we have an open circle at -1. So again, we're starting at -1, just where we ended on the last one. And the line is going all the way up to another open circle, but it's going to be at +1, it looks like. Because remember, we're only looking at the x values. So again, since they're both open circles, neither one of them is going to have the equal sign. And now I'm going to do the same thing for the last one. So now the purple one, it looks like I have a closed dot at 1. So we're starting at 1. And as I follow the line up, I'm going to hit an arrow. And just like we said before, if you have an arrow, that means it's going to infinity. So I have from 1 all the way up to, in this case, positive infinity, since we're going to the right side. And the 1 was a closed circle, so I can put the equal sign in. So in this case, our piecewise function is represented by that whole thing up there. It would work better if I had a bigger highlighter. So that whole thing up there, that is our piecewise function. So it's just going backwards and finding the equations. I find these ones more difficult than the top ones. I like drawing them out, but I've noticed in the past that some people prefer having the graph and trying to find the equations. So I'll leave you guys on there unless you want to do more practice with it and do number 4. I mean, that's up to you guys. I mean, technically, I can stay on with you guys for as long as you want because I know you don't have any other classes. It's just a matter if you're bored out of your mind and you really want to watch a math lesson. So that's up to you. So if you guys want to see it, no problem. If not, whatever. Now I'll just wait a second to see if you actually want to see it because I got to wait for your comment and it's always a little delayed and blah, blah, blah. No? Hannah says no. We don't have to. It's the same type of problem. It's just 2 lines, so we would have to do 2 equations. So don't be afraid to contact me if you guys have questions with the homeworks. For you guys, I think I mentioned it last week, only 2 homeworks a week now for Math 12. I'm going to make one due every pretty much Wednesday, and I guess I'll put the due date on Saturday. But I know most of you guys probably won't turn it until the following week anyways. So 6 and 7 were due last week. This week we're going to be doing 7 and 8. So we did 8 and 9 because, you know, that's how you count in math. So 6 and 7 was last week. 8 and 9 will be this week. And that's what we're going to focus on for pretty much however long this goes on for. If it goes to the end of the year, it goes to the end of the year. If it goes till next month, it goes till next month. I don't have answers yet. So I'll just leave it off on that. I hope you guys had an awesome Easter. I hope you guys enjoy the rest of your evening, even though that we're going to probably have like tornado weather. I don't think we're supposed to actually get a tornado, but it's supposed to be really high winds, and we probably got 60 to 70 mile an hour winds right now. I don't know how it is down by you guys. Stay safe, and I hope to see you guys tomorrow. All right. Have a good one. See you, Anna. Bye, Bye, Jenna. And whoever the other two people are in here watching. See you guys later.